Welcome to Next Gen Manufacturing Nexus. Look around you. The phone in your hand, the car you drive, our world is literally built on polymers. But the very engineers who created these revolutionary materials are now facing their biggest mission ever, solving the massive problem that their own creations helped cause. Today, we're diving into the world of the polymer engineer.
You know, if you've ever felt like this, you are definitely not alone. The lines between chemical, materials, and polymer engineering can get, well, pretty blurry. So let's clear it all up, right? What is the actual difference? And what makes being a polymer engineer so unique today?
Okay, so we're at this engineering crossroads. Let's break it down and see exactly where each of these paths leads. All right, here's the simplest way I can put it. Think of chemical engineering as being all about the process. They're the ones figuring out how to make tons of something efficiently and at scale. Then you have materials engineering. That's all about the product. They're inventing brand new materials from scratch. And polymer engineering, well, that's a super focused deep dive into just one of those materials, plastics. Arguably one of the most versatile and, let's be honest, challenging materials we've ever created. But, and this is a big but, don't think of these as totally separate boxes. There is a ton of overlap here. Your skills in one area can be incredibly valuable in the others. And that flexibility, that's absolutely key, especially when you start looking at the massive, complex challenges that polymer engineers are being asked to solve right now. So now that we know where they fit in the big picture, let's zoom in on their mission. What does a polymer engineer actually do day to day to shape our world?
I like to think of them as material architects. Seriously, they're involved in every single step, from the birth of a new polymer all the way to its end of life. One day they're in a lab, literally designing molecules. The next, they're on the factory floor, figuring out the best way to manufacture it. And then they're in a testing facility trying to break it just to make sure it's strong enough. They truly own the entire life cycle of a polymer.
Okay, but here's the twist in the story. The wild success of plastics, well, it's created a monumental problem, right? And now, the very same engineers who helped build this modern world are on the front lines trying to save it from what feels like a tidal wave of plastic waste.
And the scale of this problem, it's just staggering. Get this, in the US alone, we're talking about 8 million metric tons of this challenging plastic waste every single year. But here's the really tough part, the hard truth. Over 90% of it never, ever gets recycled. That's the mountain we have to figure out how to move.
So why are these plastics so ridiculously hard to recycle? Well, first up, you've got something called thermosets. The best way to think about these is like baking a cake. Once you bake it, all those ingredients are chemically locked together. There's no way you're turning that cake back into liquid batter, right? It's the same idea here. Their molecular bonds are permanent, which means you just can't melt them down and reshape them. Next, we've got the challenge of multi-layered packaging. You know what I'm talking about? Like a chip bag. It's actually a brilliant piece of engineering. This fusion of plastic and metal layers that keeps your chips super fresh. But for a recycling plant, it's a total nightmare. Trying to pull apart those layers that have been fused together, it's basically impossible with the methods we have today. And last but not least, foams. I'm talking about stuff like polystyrene or styrofoam. The thing about foam is that it's mostly air. And yeah, that makes it a fantastic insulator, but it also makes it a complete economic disaster for recyclers. Think about it. The cost of collecting and shipping all that bulky air is often way more than the tiny bit of plastic you recover is actually worth. It just doesn't make financial sense. Okay, so it's pretty clear that our traditional melted down recycling just isn't going to cut it for these materials. We need a totally different way of thinking, a fundamental shift in how we approach this. And that's where molecular recycling comes into the picture. It's a true game changer, a technology that attacks the problem right at the chemical level. Now, this isn't just one magic bullet solution. Think of it more like a powerful toolkit with a few different approaches. First, you've got purification, which is kind of like a super deep clean. It uses solvents to strip away all the gunk, like colors and additives. Then there's depolymerization, which goes even further. It chemically unzips the long polymer chains back into their original, perfect little building blocks. And finally, you have conversion. This is the ultimate transformation, where you can take mixed plastics and break them all the way down into valuable raw materials to make brand new stuff.
Okay, so we've got these incredible, revolutionary technologies. But what does it actually take to use them?
let's dig into the essential toolkit that every single next-gen polymer engineer needs to have.
So yeah, what does it take? What are the absolute core skills you need to master if you want to be on the front lines of this materials revolution?
All right, skill number 1. It all starts with something called rheology, and that's basically the science of how stuff flows. I mean, why does honey pour so differently than water? That's rheology. And why does that matter? Because if you're trying to inject molten plastic into a mold to make a perfect car bumper at lightning speed, you have to understand how it's going to flow. Mastering rheology is the absolute key to turning a blob of raw plastic into a perfect finished part. Next up, you've got to know CAD, computer-assisted design. At the end of the day, as an engineer, you are designing real physical things. CAD is the universal language, the essential tool that acts as the bridge between an idea in your head and a precise, manufacturable blueprint. It's how you go from what if to here's how we build it. Okay, third, you've got to master what sounds like a mouthful: thermomechanical characterization. I know, it's a fancy term, but really, it's just about using advanced tools to see how your material holds up when you heat it up and put it under stress. It's like a scientific torture test for plastics. This is how you prove for sure that a part won't melt in a hot car or just snap in half when you put pressure on it.
And finally, and please do not sleep on this one, statistics. I know, it might not sound as exciting as designing new molecules, but it is absolutely 100% critical. From designing smart experiments in the lab to keeping quality high on the factory floor, data is the language of modern manufacturing. You just have to be fluent. So you've got this awesome toolkit. Now what? Well, an incredible range of really exciting career doors swing open. Polymer engineers are absolutely essential in some of today's most cutting-edge industries.
Take the medical field, for instance. You've got companies like New Shores, where polymer engineers are creating these amazing biocompatible scaffolds that actually help the human body regenerate its own bone and tissue. I mean, think about that. This is truly life-saving work, and it's all built on advanced material science. Or look at industries like aerospace and defense. Companies like Permali rely on polymer engineers to come up with the next generation of super strong, ultra-lightweight composite materials. These aren't just lab experiments. These materials are absolutely critical for building more efficient and safer planes, faster cars, and tougher equipment. And yeah, this kind of specialized expertise, it definitely pays off. You can see the career path has some really strong salary growth. As you get more experience, the demand for your skills, especially in those high-tech sectors like aerospace and medical, really ramps up. And that means some serious earning potential. So this brings us full circle. The challenge of plastic waste is without a doubt immense, but the tools we have to solve it are more powerful than they have ever been. So the question really isn't if we can create a sustainable future for plastics anymore. The question is, who is going to engineer it? The field is waiting for its next generation of architects. The real question is, will you be one of them?